Hey guys, welcome back to the coding interview pattern video series. This is the second video of this series, and in this video we are going to cover the sliding window pattern. So if you have watched my last video, we have covered the two pointer pattern. It is almost kind of a similar pattern. In this two pointer we have taken the two pointer and we'll keep moving the pointer on either directions irrespective of each other's direction. Using kind of same things, we have the sliding window. Sliding window is like we are fixing this window, and this window we keep moving either this side or either this side. In this two pointer method, we were taking the two pointers P1 and P2, and then individually we were moving either directions. Now here we are taking the 2 points, same thing, but that using the 2 point we are formulating that window, and that window will keep moving it and we will observe the things. This pattern mostly works on the sequential data structure where we want to check some data, calculate some data like in the array, strings, etc. Okay. So let's take it like one kind of real world example or out of the technical part. Let's say you have something, this area is there. Okay, and you have been told that hey, at suppose some area at every 1 meter or maybe 10 inch, you need to observe something. So what you will do, you will have some microscope or something device, and using that one you will observe some part of that wall or that land or whatever. Once you have done this one, you will move this one to next cell part. You will move this one to next cell part, and you will get some result out of each observations. So this is like window. You keep doing something, coming here, you are getting some result, and then moving to the next, then moving to the next. You will keep moving here and there. You will keep getting some results, and at the end you may compare the result, you may analyze the result. Just depend on the requirement. In the real world also, somewhere like we have the TV channels or maybe some the server load where you want to check every interval what is the result or what is the outcome, depend on the criteria. You can use this sliding window pattern. So let's take one DS kind of example. Let's say we want to do it that we have one array. Let's take one array. 1, 2, 5, 6, 3, 1, 2, 5, 3. Now what you want to do it, you want to find the maximum sum of the k element. Maximum sum of the k element. Maximum sum of k means, like suppose let's k I am taking 3, that means maximum sum of any 3 number. So this 3, the next 3 will be this 3, then again this will become next 3, then again this will become next 3. So you see some pattern is going on. This 3 one, when I am going this 3, this become one window. Next time, once this is done, we are taking this 3 from here to here. So this also become one window. So we will keep observing 3 window and we'll getting some data. So let's say we said that hey, okay, we want to find the maximum sum of the subarray of the number 3 or the k3. So what we'll do, we will take the window as a sliding window. We take this window. So this is our window. Because our k is 3, so we'll keep the window size is 3. Now we do sum of this one. 1 to 5. Sum of this 3 is equal to 8. So we keep the 8 as the current sum. Current sum 8. And let's say maximum sum is 0, you can consider it. Okay. Or maybe you can keep the maximum negative value. Okay, or some infinity, which is some number. Now what we will do is, we compare the 8. 8 is greater than maximum, that means maximum will become 8. Okay. Once this is done, we will move this sliding window one step. So from here we are saying my next window is this. Again we'll do sum of this one, 6, 2 and 5. So it will become 13. So current sum become 13. 13 is greater than 8. So maximum sum become 13. Again we'll move this sliding window. Let's say we'll move this one to this one. Sum of this one we will do it. It will become 5, 6, 3. It's become 14. So maximum sum will become 14. I'm not updating here just to save the time. We'll move the window. This will become 10. 10 is less than maximum. So we'll not update. We'll move this window to here. This will become also 6. 6 is less than 14. We'll move the window here. This will become 8. 8 is less than 14. We'll move the window here. Again this become 10. 10 is less than 14. So that means our result is maximum sum of the subarray of size 3 is 14. And how we solve this problem? Using the sliding window. We kept sliding the window to observe or get the next result. Okay, so this is how we can get it, the result for any such problem. This was a small or simple problem, so we are not going to implement in Eclipse, but let's take one little bit complex problem, and then for that we will do programming also. So the problem is find the maximum sum. So we say that maximum sum for that subarray across the array. Now we are saying for each k find the maximum sum, each window. Okay. Now and we will use some Q and all. How, let's see how we can use all the things. Okay. So what we are saying is that find the maximum number, not sum, number of subarray of size k. Maximum number of each subarray. Let's say we say each subarray. Each subarray of size k. That means you have given one array. For each subarray of size k, you have to find what is the maximum across within that window, within that indexes. Okay. So statement is clear. Find the maximum number of each subarray of size k. So let's say we have given the, let's say take one more array. Okay. 1, 2, 4, 10, 9, 16, 11, 15, 7, 6, 4. Okay. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Doesn't matter, but size is 11. We don't need it, but just kept it in case we need it. So we given that this is the array, and for each size k, let's say now take the k is equal to 4 this time. Last time we took 3, you can take any number, doesn't matter. It's just dynamic. So what we are saying, for each subarray of size 4, find the maximum number within that window. So if we take example of this first 4, we need to find the maximum number of this one, which will be 10. Because we know it, right? But how we'll solve that problem? Using sliding window and other data structure. Okay, cool. So what we will do it here is, first thing as we said, we need the maximum number of each subarray. That means we will have the multiple numbers which we need to save in some array. So we need to have some array, let's say result array. Okay, so in this one we'll keep entering the results. Now second thing is, we will take some one Q which will be maintaining this number, so that it will be easy to derive the sum. Because else what we need to do it? We need to take the subarray, again we need to do the loop and find the maximum. Again next time, again we need to do the find loop and take the maximum number. That we don't want to do it. So we will maintain the queue, and using that queue, we'll find what is the maximum number. Okay, so let's say one queue is there. Okay. We will come back here what I'm trying to say it. Okay. So what we'll do, first we have the size of the 4. So the 4 number, we'll go with this one and we will enter each number in this queue. So first we enter. So in this queue, no, one thing, this queue we will maintain the indexes of the number, not the actual value. Again, we will maintain the index of the number, not the actual value. So first, obviously we'll start from here for this sliding window. So what we'll do it, we'll insert the 1. This is the index 0th. If I say this index, then index is 0. So we'll enter the 0. Okay. Then we'll move ahead. When we move ahead, we have the index 1. So here, whenever we will insert the new number in this queue, we will apply 2 conditions to eliminate the old values. What are the 2 conditions? So condition 1 is the eliminate all the indexes whose value is less than the current number value. So the less values. Because it's saying that, hey, I'm more strong than you, so if next time someone is going to compare with me, I will win. You don't need to be there. You can go and enjoy. So first thing is, if someone more stronger person, more powerful numbers comes, then he can release all the less powerful numbers. Because they don't need to participate in the comparison. It will win always. That is one condition. Second condition is there, if some number it's go out of the window. So it's saying, suppose I am now comparing to this one, I am just moving this window to here, then this number 1 is not part of this window. So it's saying, hey, you are not part of my window, you are not part of my community, you can go away. It is 1 in our system, it looks like that, hey, this is 1. In any case, we have the more number. But even if it is the 19, and we are comparing this window, we need to kick out this 19. It's powerful, it's strong, it's bigger, but it's not part of this community. You are saying, hey, you are not part of my community, you are not part of my window, so we will not consider it. So that is out of window. Okay. So using these 2 conditions, we will eliminate or dequeue this queue, remove the numbers. Okay. If we do this, you'll find an interesting thing is that always this first index number will be the maximum number. We'll see how to do. Okay. So I come here. We have this one. So it was 1. Let me change it. Okay. 1 was there. Index 0. So 0, 1, 2, 3. I'm putting the index 4, 5, 6, 7, 8, 9 or 10. So size 11. Okay. This time also is size 11. Nice. Okay. So we are saying 0th index we put it last time. We are coming at 1th index, which number is 2. 2 is less than, 2 is greater than 1. That means the 1 is lesser value. We will remove the 1. We will remove this index. And we will insert new one. That is one thing. Second thing, is there any out of window? Now how we will check out of window? So what we will check it? We will take the I. So index, let's say index j. So this we are considering j index. Let's assume we are using j index. Index j is less than or equal to I minus window k. Okay. So in this one, I is equal to 1. 1 minus k minus 4 into minus 3, but here only we don't have any index, we only insert a 1. If something was there, we need to compare this one. As of now we only have this one index, so we don't need to compare it, but whenever we needed to compare it, we apply this condition that hey, if this satisfies, that means it is not part of the current window. So it's clear? Let's see. Okay, now we'll move to the next one. Okay, so we are moving this index 2 we have inserted. We found that the old value, one index was there 1, one index value is 2 is less than 4, so we will simply eliminate it. We will keep only 2. Here, second condition, nothing to apply, we don't have any number, so we not apply this. Moving this to 4, 10, index 3, applying first condition, 10, 4 is less than 10, so we will remove this 2 also. So only left 3. Now this one window is completed. Okay. Now in this one, in the queue, what is the value? First value 3. Index 3. What is the value of index 3? 10. That means 10 is the result. Okay. So we got the result for the first window. Okay. Now let's say we have now once this is finalized, first time we need to capture up to the window size. Next time we need to do one increment, because first time we did 4. Now we just need to do one increment from here to here. Now we'll consider this one increment only, and we'll check every time. So this will be like one separate process where we up to window size we need to do it, and then every one increment we will compare the values. So in the queue, as of now we have 3 value at the first one, and we got the first result. Now we are incrementing 1. 9. What index of 9? It is the 4. Sorry. We need to insert in the queue. So inserting the 4 queue. Less values. So previous was 10. Index 3 value 10. 10 is not less than 9. So this first condition doesn't satisfy. We cannot remove the 3. Correct? Okay. We have some numbers, so we can check the second condition. Up to till now, we were only remaining with one number, so we will not apply second condition. But now we have one number, we will apply second condition. So at this condition, what is the I? I is the 4. What is the what it say? K. K is equal to 4. 4 minus 0. Now 3 less than equal to 0? No, this is wrong. This is j equal to 3, and I minus k equal to 0. So that means we cannot remove this number. Cool. So both conditions failed, so we will 3 will remain there only. Okay. Now, as we said, every time we keep comparing. So out of this one, we will, as we said, we will take always first number q. This one only. We will take 10 as the result, which is the maximum number. I said you that you just need to take the first number from the queue, and automatically it will become maximum number if you do this condition properly. Okay, cool. Let's go to next window. So now we are incrementing 1. We are going to this window. We are incrementing this one. So index 5 we inserted. Index 5 is 16. How many index we have? 3 and 4. At the 3 what we have? 10. 10 is less than 16? Yes. So we need to remove the 3. Right? First condition satisfied. At the fourth index we have 10. 10 is less than 16? Yes. So this condition satisfied. So we need to remove this also. What remaining? 4. Only one will remaining. That means this condition not need to apply because there is no other value to check it. That means in this window only one value is there, 5. So if we take the first value of the q at index 5, which will be 16, the next result is the 16. Correct? Okay. We'll move to the next window. So now window will come from here to here. 1, 2, 3, 4. We are keeping the 4 side, just remember it. We are coming here 11. Index number. So 5 was there, I am putting at first. So 5 was already there. Now putting the index 6. 6. At the 6, what is the value? 11. At the 5th, the old value 16. 16 is not less than 11, so we cannot remove the 5. That is correct. Let's apply the second condition because we have the value. Second condition we apply. What is the j? J is equal to 5. 5 less than equal to, what is the I? I equal to 6. What is the k? K equal to 4. That means this is equal to 5 less than equal to 6 minus 2. This is true? No, right? No. So that means this condition also failed. So we cannot remove the 5. Cool. Now in this one, we'll take the first value as I said. What is the first value of this one? 16 cube. We'll continue it. So we got the 16 of the maximum. So in this window also we got the 16. In this window also we got the 16. Now we will move the one window ahead. So we here to the here. Correct? Now we have the index 7. We will insert at the 7 index. After inserting the 7 index, we will apply this value. We have the index 5. 5 is 16. 16 less than 15? No. So we cannot remove it. Correct? So one condition is failed. Let's apply same condition for this 6. At the 6th index, we have 11 value. 11 is less than 15. That means we can remove the 6. Correct? Now we have some numbers, so we will apply second condition also. So here j is equal to 5 less than equal to I is equal to 7, k equal to 4, which is 5 less than equal to 3, which is wrong. So this condition doesn't satisfy. So we cannot eliminate this number 5, index 5. So again, we will take always first value. Index 5 is the maximum value. Correct? Now, so I am writing 7 here, just to space. Okay. Okay. Now next, let's move this sliding window one step. To this index. So next index is 8. I am inserting the 8. What we will do? After 8, we will compare the rest of the two old indexes. We will say the 5. At the 5, what is the value? 16. 16 is less than 7. No, that means this condition not satisfied. At the 7th index, we have 15. 15 is less than 7. No, that means this condition doesn't satisfy. So we cannot remove two of them. Let's apply these conditions. So if I say I minus k, which is the I is equal to 8 less than 4 is equal to 4. Right? So anyone less than or equal to 4, we can remove it, but all are greater than 4, that means we don't remove anything. So we just inserted it, we are done with two conditions. Once we are done with the condition, we just simply go to the first number, and for that index, whatever number is there, it will be considered as the maximum number. So at the 5, 16 is there, it is the maximum number, we'll move ahead to next window. So we'll move at the one step ahead. So this is the next window. Index is 9, so I'm inserting the 9. After 9, we will apply the first condition, less value. At the 9th index, we have the 6 value. Now at the 5, we have 16. 16 is not less than 6, we will not remove it. At the index, we have 7, 15. 15 is not less than 6, we will not remove it. At the index of 8, we have 7. 7 is not less than 6, we will not remove it. So that first condition, it doesn't remove anything. Let's apply the second condition. Second condition, we need to check I minus k. I is equal to 9 minus k is equal to 4 means total value is 5. So values less than 5 we need to remove it. Less than or equal to 5, j5 is less than or equal to 5, we need to remove the 5. 7 failing condition, 8 condition failed, 9 condition failed. So we cannot remove any 3. Okay, both conditions are done. Whatever we got the first value at the index 7, at the 7th index we have 15, we'll consider 15th at the result. Clear? Good. We'll move the one step ahead, and which is our last window of this array. So this is our last window. Index is 10. Okay. At 10th index we have the value 4. What is the less value? 7th index we have 15. 15 not less than 4. We cannot remove. 8th index 7 is not less than 4. We cannot remove. 6 is not less than 4. We cannot remove it. So this we cannot remove anything for condition 1. Let's apply the second condition. Second condition, I is equal to 10 minus 4 is equal to 6. So j less than or equal to 6, you can remove it, but all are greater than 6. Nothing can be removed. Okay, done. We'll check first value as I said, index 7, which is the 15. So that means this is the result. Now we are done with the last window because there is nothing to go beyond that. So finally, this queue we can discard it. No use of this one. And this is our the final result of each subarray of size k. These are the maximum number. On this one 10 is there. On this one 10 is there. On this 16 is there. On this 16 is there. This one, then this one 16 is there. Then this one 16 is there. Then this 15 is there, and then this 15 is there for window. Clear? Good. So now we will go and implement Eclipse, how we can take this queue, how we can save the result, how we can move the window, how we can apply these conditions to clean up the queue. All the things will work on the Eclipse. One note guys, you may find some issue, maybe some gap within the video. My mobile device was getting hot, so due to that I have to restart the video. So somewhere you may find the pause or sync issue. Okay, so please excuse me for that. Let's meet on the Eclipse.
Hey guys, so let's start our coding for the sliding window example. So let me create a new class here. Let me give this as sliding. Okay, so we have this class max number of sliding window in array, and we'll start with our implementation of our method public and what will return it. Static. We know it was returning the integer array, so find the max number of sliding window of each subarray. I can say it. It's getting big, but you know in the video what it means, so it's fine. Okay. Return statement we can edit, it is fine. What we need, what we'll get it here, we will get the array. So let's say we get the array as numbers, and we will get the window size k. Correct? Okay. Now as we said initially, we need two things. What we need the result array. So this will be results of integer, will put it. Now thing is, what will be size of this array? Because when we saw in the videos, we were just keep inserting it, but in this Java program we have to give the default values. So the size of this will be whatever we have the numbers dot length minus our window size plus we need to do 1. You can calculate from the video that how we derive this length, but this is what we needed. Second thing, we said we need one queue to maintain that data. Now let's take one queue. Here, if you know the queue, it's FIFO, first come first out, right? But here in our case, we may need to add the element at first and the last, we need to remove from first or last. To allow that operation and to do it, we will not use the queue simple, we will use the DQ. So let's say I'm saying this one as, let's say it's keeping it queue only name, and let's put it array queue. So this is the implementation of the DQ. Okay, so our two requirements are clear now, that we have the queue and we have the results. Now what we need to do it, we need to start traversing the array. Now we need to traverse in two different loop. One is for window size and then for the rest of number. Because first window size, it will be like once we have all the elements, then only we'll be able to compare it. So we need to compare for the window size k, will traverse it, and then we'll traverse for the rest of numbers. We'll do one increment and we'll compare the number. But first time we need to do for the window size. So our window size is k. So for integer I, will start from 0 up to, we will do I less than window size, which is the k, and I plus plus. Because up to this we don't need to, we cannot derive the number. First we have the, like suppose window size is k4, then first we need to have the for number, then only we can say okay, out of 4 this is the maximum. So first time we need to have the for number. So this for number, what we will do it, we will add this number in the queue, and which is nothing but what. So yeah, remember I was you made mistake. I was about to make the mistake is I was just trying to add the numbers. I was just trying to do like this. I mean, like I was about to do this one, but remember we were not saving the data or the value in the queue. We are saving the index in the queue. Remember, so here we will save the index. Now we need to do cleanup process. We said that we need to at every insert we will to apply the rules to clean up the queue. Okay, and we will do clean up this before inserting it. In the video maybe we are doing the after inserting, because these were all the explanation, but here we need to have the as per process, and we need to make sure that it works in all the cases. We will do the cleanup before the process. So now to clean up do it, we'll maintain the separate method, and we can call it. So here we saying public static, I'm making method and saying method name I'm keeping clean up the queue. So clean up queuing means like it will apply the two rules what we discussed in this one, and finally it will also return our same DQ after cleanup, final one. Okay, it will clean up the same queue. So what we'll do it in this cleanup queue, what we need it here, we need first we need that what is the current index, if you remember it, that hey, what is the current index, because to apply the first rules we need the current index, then only we can compare the other value. We need the window size, okay, and then we need the whatever we have the DQ, current DQ we are using it, that current queue I mean, plus we need the array, whatever actual numbers what we've got in the method. Sorry, I have put inside this one, let me copy and cut and paste here. Okay, cool, and I'm returning the same queue here. Okay, so this is fine. Now we'll apply we have the two rules, right? Remember we have to apply two rules here. First rules, remove all less values, okay, or small numbers I can say it. So that means less than current number, less than current number we need to remove it. So less than current number, we can have the multiple numbers. So we need to do this in the loop. In the loop, what we'll say, okay, till we do this one till this is not empty, because till the queue has some value. So that says, sorry, till it's not empty, and whatever value we have, these numbers we have, current value is number i's, you remember it, greater than or equal to the numbers of, so this is again, we will check, see in the queue what we have. In the queue we have the index, so we cannot compare the index, we need to get the value of this one dot get last. Okay, so why we are checking the last is because as per this one we are inserting this one, we know that if this will fail, then rest of all will fail. It doesn't will happen that hey, this is not satisfied, for next element it will satisfy. No, if this number is bigger, then all the other numbers will be bigger than this one, so we don't need to check rest of things. If this is smaller, then there are chances that other can be small, so we'll go with this one. So if you found that last number is less than this our current number, then we will remove that last number. And now you remember, you will notice that why we use the DQ. We want to remove the first or last dynamically based on our requirement. So this loop will keep checking the last. If last is bigger than this number, then all other rest of will be bigger. We want to check that one, because that was, if it was smaller, then it might have removed in the last round, because every insertion we are checking these conditions. So we are sure that all will be bigger number. Then remove the out of window index. Okay, remove out of window access. So what we are saying is, if any index, so now here we don't need to have the loop, because we know that every insert we are checking this condition. So every insert there can be only maximum one index which is out of window, because we are incrementing one number, so that means maximum there will be one number, correct? So we are doing here also, we check if queue is not empty. If queue is not empty, and whatever we have, this one dot get first, the first one whatever we have, we are removing from the front, the first one is less than or equal to, remember the condition, I minus window size k. Then we'll remove that first, because we know that the first one will be out of the window. Whoever was inserted first time, it will go the first out of the window. So we say remove first. Correct, here both conditions we applied, and finally we are returning the queue. So again, two rules, two conditions, you can say rule, you can say conditions we applied, and we are cleaning the queue. So here, before applying this one, we will always clean up the queue. Queue is equal to, we will do the cleanup. Clean the queues, correct? Cool. So this up to 4, whatever size is there k, we just need to keep inserting this, and we know we have nothing to decide that hey, which is the big number. Once we have this 4 number inserted, okay, then you remember we said that we are doing in such way that our first number will be always the bigger number, always the maximum number. So what we'll do it for this results, by default for the size at the index of 0, and because we are doing first time, we can check q dot, what we need here, we need the first number. Okay, so we'll just simply insert that, okay, get first. We're not removing anything, we are just simply inserting it. So we got the first number. Now we need to have the travel rest of the number. So what we do from integer I, now we know up to k we have already traversed. So we'll start from the k here, k, and up to array length, numbers dot length, I plus plus. In this also we'll do same thing. Whatever, I'm just copy pasting number value from upper one. We'll do the cleanup process. We'll do the number. Okay, so what we did in this first window, we just inserted that for numbers or the k numbers, and then based on that we decided the maximum number, which is the first number. So but here we already have that window prepared in the first one, so at every insertion of the new number we need to decide the next maximum number. Okay, so what we need to do it here, we need to keep inserting the results at some index j. We need to keep inserting the last first number, so which is q dot get first. But what will be the index? So index, we know the I we started with the k. That means whatever I we have, if I remove the k, it will become 0 in this first iteration. But I already inserted 0th index, so I will insert with the 1 index. So I will do plus 1. So every time I will keep incrementing, this will incrementing 1, 2, 3, 4. Or you can say it is same as like I'm deciding the j is equal to 1, because n I'm putting j plus plus, and here I'm just keeping the j. I just started with 1 because the 0th index I already covered here. Okay, so this is same, but I'm keeping the proper one. Okay, fine. So this we are done both. We have inserted this window and we have done cleanup also. In this also we have done cleanup. We have implemented the cleanup method also. Now it's time to run this one and test it how it looks. So to this one we need the pass the array. So let's take one array. Let me take simple array. So I'm taking 1, 2, 4, and 2, 3, 4, 5, 6. Okay, and let's put this one. So it will also return the array result. Results is equal to I can pass the array, and let me pass the size at the window 3. Okay, now let's print this one. We need to print at the string. Okay, so we have the 3 windows. The first 3 window, the so what is expected is, let's see it first. So we have window of 3. The first 3, the number 3 is maximum, second 3, 4 is maximum, and I think then 5 is maximum. So 1 window, 2 window, 3 window, and 4 window. Last will 6 will come. So this is what expected result is. Then let's run it now. It's 2, 3, 4, 5, which is the other than the our expected value, but I see some one number is more than this one. So instead of 3, 2 is there. Okay, so wait, well, let's see what we have done wrong here is we have taken the cleanup process, we have added the q, we have added the q dot first. Here also we added the q dot first. So yeah guys, see what we said here in the videos also, that in the q we are inserting the I is nothing but index. So we are inserting the index, not value. and we took the index as it is. So here index got printed 2, 3, 4, 5. So index 2 is the value 3, index 3 is equal to value 4, index 4 value is 5. So we need to change these values. We are doing mistakes here. Numbers dot, sorry, this is not a list, this is just array. So I just need to do like this and something here, get first, correct. Let's run it now and let's see. 3, 4, 5, 6. So cool. So this is our expected number. Now let's put what we have put so in the video. Same number here we can put it and see how it looks. 1, 2, 4. I'm just putting exact number what we saw in the video. I just 16 was there, one, then what was there, 11 was there, 15, 7, 6, 4. Just if I'm making any mistake, please correct me. You can just run. Let's run this program now. And what we say, 10, 10, then 16 4 times, and then 15. If I see the whiteboard, I think this is the same, 10, 10, 16, and 15, 15. Yeah, you can check also. So this is how you can implement this program. So you can just check with the different inputs. Now few things here we need to take care of the few edge cases. This can give some errors in some edge cases, like if this number is equal to null or it is empty. In this case, you can just pass the new integer 0. Okay. What type did it? So I just need to put double equals. Okay. Again, it depends on use cases. If you somewhere is mentioned explicitly what you need to do it, you can do that case also. Second thing, if the window size k is greater than numbers dot length. Here also depends on your whatever mentioned, you can throw the error, or you can assign the k is equal to numbers dot length. You can do it whatever is mentioned in the test cases or description. If not mentioned, you can choose to assign maybe the second option, this k equal number length. Fine. So that's it, I think. Yeah, you can try it in Eclipse and let's see it how it looks. Maybe you can try it before. Don't see this coding, just see the video. Check this, follow the step-by-step process, and we'll be able to do it.
Guys, one thing, while you're doing the coding, you might have noticed that while applying these first rules, we were using the get last and the remove last methods. While applying the second rule, we are using the get first and for comparison, and then remove the first for the removal part. While we are doing this, explaining these things, we didn't focus on this. We just compared across all the numbers, but we don't need to compare across from both sides. We can start from the one direction and then we'll be able to achieve it. So why I said get last is, you remember in the queue, when suppose we have the few numbers, we are saying always the first will be maximum number. That means all other are the decrement, descending order. So now what it's saying is get last, that means get this number for comparison. Why it's saying this one is that if this is less than me, I can check other. Because if this is descending order, so this is the smallest value. If I cannot beat this one, I will not able to beat others. So that's why I say get last. So if the last is smaller than you, then remove this one, then this become your last. Again compare this one. If you are not able to beat it, it's not less than you. That means all other will be always more than you. You don't need to check that part. So that's why the get last and the remove last works. Same thing on the out of window, we are using get first and remove first. That was not for loop, that was only if condition. Why I saying get first is this number. So this number will be always the smallest index in this one. See, I said it is in descending order, that is the values, not the index. So values will be descending order. So this will be the maximum value, but I'm not saying that index will be maximum. So this index will be the minimum index, or you can say leftmost index. Now, why we are saying this one is that once 2 came, it kicked out 1. 4 came, kicked out 2. Now when we are saying that if something is out of the window, then it will be the leftmost only, because we are moving the window on the right side. So if you have moved a window for one size, that means the leftmost, the 1 will be out of the window. So we will say the get first. So the first whatever is then left side is out of this, then remove this. Now as we are doing this at every incremental, we know there will be no more than one such value. There will be only one value. So we are not doing in the while condition group, we are only doing in the if condition, and we kick out, we remove it, or we do the remove first. So hope this all the clear. You can try it. There are some other such problems you can try it. Maybe you can create it, or maybe you can something find that, hey, find the some string of the big string, or maybe the repeated characters. You can just create problem by your own self and try to solve it. Okay. So we'll meet in the next video. Thank you guys for watching.